You're sitting in a technical interview for a data engineering role. Your palms are sweaty as the interviewer opens their notebook filled with PySpark questions. But don't worry, I've got your back. Let's tackle the most common PySpark interview questions and answers so you can pass the interview and land that six-figure data engineering job of your dreams. Let's start with the basics, your interviewer says. What exactly is PySpark? PySpark is Python's API for Apache Spark, a distributed computing system. It's built around two core components, Spark Context, which is your connection to the Spark cluster, and Spark Session, your unified entry point for modern Spark operations like data frames and SQL. Tell me about RDDs. What makes them special? RDDs, or Resilient Distributed Datasets, are Spark's fundamental data structure. They're special because they are resilient, meaning they can rebuild lost data using lineage graphs. They are distributed, with data partitioned across cluster nodes. They are immutable, so once created, they can't be changed. They are fault-tolerant, meaning they can recover from node failures. What's the difference between RDDs and data frames? This is where many candidates stumble. Data frames are like RDDs with superpowers. They have a schema with named columns and data types. They support SQL queries. They use the Catalyst optimizer for better performance. They automatically infer data types. They integrate seamlessly with machine learning libraries. Explain Spark's lazy evaluation. Why is it important? This is crucial. Spark uses lazy evaluation through transformations and actions. Transformations, like map and filter, create execution plans without processing the data. Actions, like collect and count, trigger actual computation. Lazy evaluation allows Spark to optimize the entire pipeline before execution. For example, filtering data before a join is more efficient than joining first and filtering later. How do cache and persist differ? Great question. While both store data in memory, cache is shorthand for persist with a memory-only storage level. Persist offers more storage level options, such as memory only, memory and disk only, memory only serialized. What are broadcast variables and accumulators? These are special shared variables in Spark. Broadcast variables are read-only data shared across all nodes. They're perfect for lookup tables or machine learning models and reduce data transfer across the network. Accumulators are variables for aggregating information. Only the driver can read their final value, while workers can only add to them. They're great for counters and sums. How would you optimize a slow-running PySpark job? This is where your detective skills come into play. Start with memory management. Cache frequently accessed data. Use broadcast joins for small tables. Monitor shuffle spills. Second, data distribution. Right-size partitions at 100 to 200 megabytes each. Use repartition for increasing partitions. Use coalesce for reducing partitions. Third, join optimization. Choose appropriate join strategies. Minimize data shuffling. Pre-filter large tables before joining. Explain different types of joins in Spark. Spark supports multiple join types. Shuffle, sort, merge. Join for large tables. Broadcast hash. Join for small tables. Inner, outer, left, right, and cross joins. Best practice is to broadcast smaller tables using broadcast. How do you handle missing data in PySpark? Several strategies are available. Drop to remove rows with null values. Fill to replace nulls with specific values. Replace to substitute values meeting conditions. Advanced options use window functions or ML imputation. What's the difference between repartition and coalesce? Both change partition count, but repartition does a full shuffle and can increase or decrease partitions. Coalesce does optimized shuffle and only decreases partitions. Use coalesce when reducing partitions for better performance. How does structured streaming work? Structured streaming treats real-time data as an unbounded table. It supports micro-batch and continuous processing. It handles late-arriving data with watermarking. It provides exactly once processing guarantees. It integrates with DataFrame API. When should you use PySpark versus traditional Python? PySpark shines when data exceeds single machine memory. Distributed processing is needed. Working with diverse data sources. Real-time processing is required. Building ML pipelines at scale. Remember, the key to acing these interviews is understanding not just the what, but the why behind each concept. Practice these questions, and you'll be well prepared for any PySpark interview that comes your way. Make sure to check the description for exclusive resources and tools to help you become a master of machines. Watch again if there's parts that you missed.